Hey guys, what's up? Mr. Miller here, bringing you another tutorial video. This one, I'd like to show you how do we find area of rhombuses and kites. The cool thing about this topic is it's two for the price of one. What I mean by that is whether we're looking at a rhombus or looking at a kite, the formula to find its area is going to be the same. Before we get into what's the formula, and how do we use it? Let's talk about what a rhombus is. So a rhombus is a parallelogram, which is also a quadrilateral because it has four sides, with all sides equal. So if you picture a square and somebody standing on that square and pushing on the side of it to make it tilt, but not tip over, that gives you an idea of what a rhombus is. A kite is a quadrilateral. It's also so that means it's a four-sided figure, and it has two pairs of congruent adjacent sides. So that means that we have two sides of one length, and then we have another two sides with a different length. And they're touching each other. They're side by side. So let me see if I can show this. Yeah, okay, I got something to, okay. This side and that side are adjacent sides. They're touching and they're the same length, congruent and adjacent. These two sides are also congruent and adjacent. Now, the formula for the area of a kite or a rhombus, it doesn't matter which of the two you're looking at, the formula is going to be the same, is we take the diagonals, we multiply them, and then we cut that quantity in half. So another way to express this formula is like this. If you don't like the fraction sticking out in front, you can write it like this. D1 times D2, and then push the 2 in the downstairs. Push it underneath. All right, so let's do an example together. Find the area of the rhombus shown below. The values shown are half the entire length of the diagonal. So what it's saying is from here to there, it's 8, but we want the whole diagonal. So this is also 8, which means this blue diagonal is how much total? 16, right? We'll call this D1. Since it's the first diagonal we're working with, why not? Let's check out our second diagonal. From here to there, it's 12, but I need the whole diagonal. And since it's a rhombus, this is also going to be 12. Okay. And the total length of the diagonal is 24. Okay, you can add 12 and 12, or you could double 12. 12 plus 12 is 24. 12 times 2 is 24. Either way, you get the same answer. And now let's find the area. Area of a parallelogram. Oh, parallelogram. Duh, no. Sorry. It is a parallelogram, but specifically a rhombus is D1 times D2 divided by 2. So we go 16 times 24, and we're going to divide that by 2 after we multiply. And let's see, what am I getting here? 16 times 24, I get 384. Cut 384 in half, and our final answer is 192. Let's take a look at another example. Now, this one is a little bit more complicated. I've taken this directly from Math Excel, so it'll be a problem that you'll be practicing after you watch the video. Notice that they have given us information about one of the diagonals, but not, we don't have everything that we need. I do know that if this is 15, then so is this piece. But I need to know what this diagonal is too. How am I going to figure that out? What we need to do is fall back on right triangles, right triangle stuff. And in this triangle, what's my hypotenuse? 25, right? Side from the right angle, 25. So first I'm going to find what this length is with the question mark. And I'm looking for a leg. 25 is my hypotenuse. 15 is my other leg. And I'm looking for this leg. All right. 25 squared, how much is that? Are you thinking 625? 15 squared, 15 times 15 is what? 225. We're going to subtract 225 off. That's looking good. And we get a nice number. We get 400, which is a perfect square. If I take the square root of both sides, square root of 400 is 20. So I now know what that question mark is. That question mark is 20. And if that piece of the diagonal is 20, so is this. And now I have all the information that I need. I have the length of my two diagonals. One diagonal, we'll call it D1, is how much? What's the entire length? 30, right? 15 plus 15. My other diagonal, we'll call it D2, is 20 plus 20, or if you like, 20 times 2, and that's 40, right? And now we just dump those two numbers into our formula and compute. D1 I said is 30. D2 I said is 40. Divide that by 2. Okay, 30 times 40, that's going to be what, 1200? Divide that by 2. How much? Our area is 600. And specifically, since we were given units, I'm going to put the units. Square inches would be our final answer. Okay, so far so good. If anything is throwing you through a loop, I encourage you to pause the video and call me over and ask. I don't expect you to watch the video straight through. If something comes up that isn't clear, call me over and I'll be glad to clarify. Okay, now let's move to finding areas of kites. The formula for the area of a kite is going to be the same formula that we use to find the area of a rhombus, but kites are kind of their own animal in a way. Let's check out what's happening here. First, let's ask ourselves, do I have the lengths of my diagonals? This length right here is a total of what? What would this diagonal be? We'll call it D1. The length of this diagonal is 4, right? 2 meters plus 2 meters is 4 meters. What about my other diagonal? This piece right here is 4 meters. This piece right here is 1. What's the total length of my kite? 5, right? 1 plus 4 is 5. This is what I would like you to do right now. We're using the same formula that we did before. I'd like you to work the area for this problem out on your own. Please hit the pause button and work it out and then check your answer. Hit pause right now, please. Well, check it out. I got 10 square meters for the area. Our first diagonal was 4. Our second diagonal was 5. We dropped those two numbers into the formula. Multiply, divide. 4 times 5 is 20. 20 divided by 2 is 10. And we just try to remember to, on paper, attach the unit to the number. Square meters. Over here on the side, I'm just showing an alternative way that you can compute this. The advantage of doing it this way is you'll end up multiplying smaller numbers. 2 times 5 is 10 versus 4 times 5, which is 20. The point is there's more than one way to get the answer is what I'm getting at. This method right here isn't the only way. You can cancel common factors out, then multiply, and then divide if necessary. All right, now let's do our last example. Let's see what shakes loose with it. Find the area of the kite. So what I would like you to do is to work this problem out on your own. Pause the video, work it out, check your answer. Pause that video right now. All right, algebra and geometry homies, check it out. I got 24 square meters. Some of my Algebra 2 students might watch this video too. That's why I said Algebra 2. Check it out. The length of one diagonal is a total of 6. The length of the other diagonal is 8 because of the 6 and the 2. Combined together gives 8. 6 times 8, 48. Divide by 2 takes us to 24. All right, that concludes the video. I hope that you found it informative and helpful. And if there's any questions when you bring your notes up to me, you can ask me those questions. I also want to say that if you tell me when you give me your notes and I ask, do you have any questions? If you say no, I don't assume that means that you're not going to have questions later. It's okay if you start the assignment and you get stuck and you have questions and you call me over. That's okay. All right, guys. Thanks for watching the video. I appreciate it. Catch you on the flip side. Bye-bye.